This is the Essentials of Political Analysis. I'm Philip Pollock. Recall that a hypothesis suggests that if we separate units of analysis according to their values on the independent and compare their values on the dependent, we should find a difference. The difference, of course, that's specified in the hypothesis. When the dependent and independent variables are measured at the nominal or ordinal level, sometimes called categorical variables, we test the hypothesis using cross-tabulation analysis. When the independent variable is nominal or ordinal, and the dependent variable is interval, we test the hypothesis using mean comparison analysis. Let's look at crosstabs. A cross-tabulation shows the distribution of cases across the values of the dependent variable at each value of the independent. Recall this hypothesis and then we'll test it. In a comparison of individuals, Democrats will be more likely than Republicans to favor gun control. Here's a cross-tabulation testing the hypothesis. Has been set up according to protocol. Let's have a look at this and then we'll review what we see. Notice that the values of the independent variable define the columns of the cross-tabulation. So everybody in this column is a Democrat, 2,043 of them. All the independents are here, 2,240. And all the Republicans are here, 1,593. And then the entire sample, all partisan groups combined, defines the total row. So think of these as silos. As you're going across, you're comparing this group of respondents, Democrats, with this group and with this group. Accordingly, the dependent variable is represented on the rows of the cross-tabulation. You see the two values here, more difficult, same, and easier. So we would test the hypothesis in this case by either comparing across values at the more difficult row, on the more difficult row, or we can compare across partisan groups in the same or easier row. Let's look at rules for setting up a crosstab. When it comes to cross-tabulation analysis, the rules are more important than in mean comparison analysis because there are more ways to get it wrong. Rule 1. Set up a cross-tabulation so that the categories of the independent variable define the columns and the values of the dependent variable define the rows. The independent variable partisanship goes on the columns, the dependent gun control opinion goes on the rows, as we saw. Now here's a cardinal rule, and this is one that's easy to violate, so you just have to pay attention to this one particularly. All of them are important, but this one can really throw you in the wrong direction if you do it incorrectly. Always calculate percentages of categories of the independent variable. Never calculate percentages of the categories of the dependent variable. So for example, we want to calculate percentages of Democrats who favor gun control and take the other category of gun control. Percentages of independents who favor, percentages of Republicans who favor. So we're calculating percentages of the categories of the independent. We don't want to know, for this hypothesis, the percentage of, say, those who favor gun control who are Democrats, independents, and Republicans. That's the wrong kind of calculation to make. Never calculate percentages of the categories of the dependent. The visual cue in cross-tabulations is that the percentages must sum to 100 or 99.9 with rounding error, or 100.1 with rounding error at the bottom of each column. Must sum to 100% at the bottom of each column. Interpret the crosstab by comparing percentages across columns at the same value of the dependent. We could compare, to continue the example, the percentage of Democrats in the more difficult value of the dependent variable with the percentages of independents and Republicans in this value. Alternatively, we can compare the partisan groups across the other category of the dependent, same, easier, but do not mix and match. Always stick to one value of the dependent. Well, interpreting the crosstab, focus on the percentage of partisan groups favoring stronger restrictions. So we'll look at that category of the dependent. Democrats are most in favor, 64.4% of them. Independents show weaker support, 45%. And Republicans are the least likely to favor. So it would appear that the hypothesis is supported by the analysis. Each time we change the independent variable from Democrat to independent to Republican, the distribution of the dependent variable changes in the hypothesized way. Okay, let's do another example so to get comfortable with it. In a comparison of individuals, young people will be more likely to support same-sex marriage than will older people. Let's test it. Here's the crosstab. Now we have more categories of the independent here. 18 to 30-year-olds are in this column. 31 to 40, 41 to 50, 51 to 60, 61 and older in this column. And to reemphasize, the percentages are of categories of the independent. So, for example, 53.3% of the youngest group say same-sex marriage should be allowed. 46.7% say not allowed, summing to 100% at the bottom. And do that for each age group. And you can eyeball these numbers. You can see as we move across values of the independent at one value of the dependent, the percentages saying allowed declines. Focus on the percentages in the allowed row. What do you think? Is the hypothesis supported or not supported? Well, let's just go back real quick and look at the crosstab again. It would appear that the hypothesis is supported. If age had nothing to do with same-sex marriage opinions, then as we went across values of age, then the percentage would be very similar within age groups. But you can see they're not similar at all. In fact, the percentage of saying allowed drops over 20 percentage points from the youngest group to the oldest group.